All right, continuing with our study on chemistry, at least the first part here in describing matter. I am going to reiterate the importance of knowing these terms. Again, the first chapter here is a lot of key terms that will be used throughout other chapters to help explain chemistry and what scientists do with chemistry and how they study it and all that. So again, I am going to reiterate that you need to know these terms. So again, make flashcards if you need to, study them every night. You need to know them or you're not going to get far in chemistry. So again, we are talking about elements, and we left off with the periodic table and you made a list. So continuing with that, elements are, again, we can break them down. They are broken down into atoms. Each individual atom is an element, you could think of it. Each element has an individual atom associated with it. These are um, different depending on your atom, depending on your elements, sorry. You can note here that this slide has a list of all the common elements that are, or at least some of the common elements that are found in the human body. You'll note that the little graphic shows a different picture for each of them. These are models of them. These are not exactly what they actually look like. They are microscopic and you cannot see them, but this is our best guess on what they look like. Actually, these aren't the greatest guesses. But the point being right now is that they are different for each element. So hydrogen looks different than nitrogen. Calcium looks different than oxygen. And because they are different, they have different properties. This is different physical properties and different chemical properties. So what happens when we put two atoms together? Well, if the property suits, they will combine and form a chemical bond. This is an attraction between the two atoms. It is a force in nature that will stick them together. They will either transfer electrons or share electrons in order to do so, which we'll get into more depth later on. But when they do combine, we do call that a chemical bond. When those two or more atoms are held together by chemical bonds, we call these things molecules. You've probably heard the word molecule before, when especially talking about water. Water is two hydrogen atoms and one oxygen atom. Together, they make a water molecule. So oxygen, the kind you breathe, is O2. It's a diatomic molecule. It has two oxygen atoms that are bonded together through a chemical bond. Carbon dioxide, you've probably heard of as CO2. Again, we have a carbon atom and we have two oxygen atoms that are held together by chemical bonds. Remember that all matter is made up of these elements, and all elements are made up of atoms. So it kind of is a hierarchy here. However, atoms are combined with other elements, or elements are combined with other elements to make up substances. So again, we mentioned substances are always going to be the same formula. We talked, or at least I mentioned a little bit about table salt, which is sodium here, and chlorine. So sodium chloride comes together and creates table salt. That is your pure substance. Sodium is an element, chlorine is an element. Together they make a molecule. That molecule is salt. Salt is a pure substance. Pure substances are going to be made up of two or more elements at a combined ratio. So this ratio idea is extremely important. It is a ratio. Depending on what you're combining will determine your properties, your physical and chemical properties. Water is always going to be H2O. However, if it is H2O2, that's hydrogen peroxide, that is poisonous to you, and you should not drink that. However, H2O is fine to drink, and your body actually needs it to survive. Another good example of this ratio being extremely important is between carbon dioxide, which is CO2, versus carbon monoxide, which is CO. Carbon dioxide is a natural occurring gas that your body expels during respiration. When you breathe in, you breathe in oxygen, right? You breathe out carbon dioxide. Carbon monoxide is a poisonous gas to you that if you have too much in your body, you will die. The only difference between the two at the chemistry level, what a chemist will look like, is that ratio. They both are made of carbon, they're both made of oxygen. However, this one has 2 oxygens and this one only has 1. It changes their properties. So that set ratio is extremely important to know. And if you are recording molecules like such, you do record that ratio, pay extra attention to it. Next group of matter we have are mixtures. Mixtures are made up of 2 or more substances that are put together, but there is no chemical bond. Right? There's no chemical bond, there's no ratio to it. I'm just throwing 2 things in a pot and saying, hey, I got this mixture. You can think of that as a salad or soil. Using the salad example, you can easily tell where one of the objects in the salad ends and the other begins. That is one telltale sign that this is a type of mixture. However, that can be confusing. The key is that there is no chemical bond. So each substance still has its individual properties here. They are not chemically bonded. You do get 2 types of mixtures. Our heterogeneous mixture, which again, if you remember from last year, the word hetero means different. The word homo means same. So heterogeneous, if they are different, then you can actually see the difference between them. Again, your salad, you can see where one starts and one stops. I can just tell you, hey, pick out all the carrots in your salad, and you can easily just pick them out. They are easy to separate because they are not chemically bound, and you can easily tell the difference between them. Your homogeneous mixture, on the other hand, is a little different. They are still not chemically bound. This is still a mixture, so there's no chemical bond, there's no set ratio, but it is kind of harder to pick them apart. Examples of homogeneous mixtures are going to be like brass and Kool-Aid and air. I'm going to start with Kool-Aid here. When you make Kool-Aid, it only looks like one substance. It only looks like Kool-Aid is in there. But really, it's a mixture of water and sugar and probably some colorings and other different things that you decide to put in there. There's no set ratio. Some of you might like a lot of sugar in your Kool-Aid. Some of you might like a little. But the set ratio isn't there and there's no chemical bond. It just looks like it's one uniform substance. It's not really, it's a mixture though. So these are the kind of the harder ones to find. Brass is an alloy. It is a mixture of 2 metals. So that's not really a pure substance. And air, again, you got your nitrogen makes up like 80% of your air. Then you got your oxygen, carbon dioxide, and you got trace gases of methane and different pollutants that people might throw in there. So it is a mixture. There's no set ratio there. Another word for a homogeneous mixture is a solution. So whenever I say solution, I am talking about a homogeneous mixture. Again, you could think of it, this is just water and food coloring. It looks like one substance, but really it is, the food coloring isn't bonded to it. And if you tried really, really, really hard, that you could probably get the food coloring out of it. You just gotta pump it through a bunch of purifiers. So we do have compounds and mixtures as well. Compounds are going to be difficult to separate. Again, they are going to be chemically bonded. And mixtures, they are fairly easy to separate by different means. You can think of evaporation, filtration, magnetism. But compounds have chemical bonds, mixtures do not. So looking at our just a little breakdown, we do have matter, which is your category for everything. Matter you can break down into either pure substances or mixtures. Mixtures you have homogeneous, which looks uniform, looks all the same. At the atomic particle level, you can see that the different things are not really mixing, they're just kind of floating around in there. Heterogeneous mixtures, again, you can tell the difference. You know when one stops and one starts. On the other side, we do have substances. Substances do require that chemical bond at a set ratio. Sometimes these substances are just one element. For example, helium. Helium is just one element. It will just be one particle. It will never bond with anything else. It's one of our noble gases. It doesn't combine with anybody. Anytime you have helium, it's just helium. Or you get to the compound, which would be like your molecules. You'll get water, which is H2O. This is carbon dioxide, it looks like. you have the the one carbon in the middle and two oxygens in the back. They tend to bond like that. But other elements do that as well. But there is a set ratio with your compounds and making your substances from.